Hello students, we are continuing the topic scales and vector, which is a complete chapter, scales and vector quantities. And in today's class we are discussing the topic resolution of a vector, which is just opposite to the addition of vectors. And addition of vectors, we are adding two or more than two vectors to get a single vector. But in resolution of vector, we are splitting a vector into its component. So the splitting of a vector into its component is called the resolution of vector. Let's say we have a vector here. Okay, some of the vectors, a vector in two coordinate system will be splitting up into its two component, one of its horizontal component and the second is into its vertical component. And while the vector in three-dimensional system will have three components, one component with the horizontal, second component with the y-axis, third component with the z-axis. So in such case, when the vector is in three-dimensional coordinate system, so it will have three its component: x component, horizontal, vertical, and the component with the z-axis. So these will this kind of vector which is in three dimension, that will have three components. Okay, now let's say we are starting from the two-dimensional system and we have this dimensional system, two coordinate system. This is x-axis and this one is the y-axis, okay, plus y-axis, and this one is x-axis, so plus x-axis. Okay, now we have a vector. Okay, first need to try to understand that if a vector is along the x-axis, mean it makes a 0-degree angle with the x-axis, so it can't be split into its component. Only those vectors can be split into its component which makes an angle theta with the horizontal axis. Okay, so if a vector is along the x-axis, for example it is in this direction, so it's not in two-dimensional system, it's only in one-dimensional system because it's along the x-axis and it has only one component and that component is x component. Okay, so this is not in two-dimensional system. The vector which is in two-dimensional system or in three-dimensional system, so that will be split into its two or three components. Okay, so we have a vector which makes an angle theta with the horizontal. Let's say we have this vector, sorry, let's say we have this vector and it's a vector A. It's a vector A and making an angle theta with the horizontal x-axis. Okay, so now how can we split this vector into its component, and that will be the resolution of the vector. So by dropping perpendicular from the tip of the vector on the horizontal x-axis, horizontal axis or x-axis. So now we will have two of its component. One is the horizontal component which will be called ax, and the other one is y, vertical component of the A, which will be ay. Is these two components are perpendicular to each other, you can see this one, that there is a 90-degree angle between these two components. That's why they are called the rectangular components. That's why they are called the rectangular component of the vector, because they makes an angle theta with the 90-degree. And if you draw it here, for example, parallel for ay is here, that is ay, and for x-axis is here, so you can make a rectangle here. So these are called the rectangular component because when you complete both of the options, ax and ay, you will get a rectangle. And so in these two components, they are making an angle of 90-degree. That's why they are called the rectangular components. Okay, now you can see that there is a right angle triangle. Okay, this angle is 90-degree and this is the perpendicular and this is the horizontal, and this will become the hypotenuse. So it's a right angle triangle. Okay, so we can use, for the horizontal, we can use cos theta. Cos theta is equal to base upon hypotenuse. We know this one, base upon hypotenuse. Hypotenuse, base is ax. Okay, do it here. Cos theta is ax upon a vector a. Okay, so I need to find out the magnitude of this one, so that's why I'm just putting the magnitude of the vector ax. Now ax is equal to a cos theta. A cos theta, or in vector form that will become ax is equal to a cos theta, and for the direction, because this is a vector now and this is the magnitude, for the direction you can put I, which is the unit vector with the magnitude of this vector. So that will become in the vector form. Ax is equal to a cos theta I. I is the unit vector for the horizontal component. Okay, now here is this value, and you will need this value when we will find out, when we will add the component with a vector by its rectangular component, two vectors by its rectangular components. So we will need these values. So you need to try to understand this here, because I will put the formula there, and that will need for you that time, because when I will put ax is equal to a cos theta, so you must understand that ax is the formula which is used for this one. Here we get that formula from here. Oh, now second thing is ay. Okay, sin theta. By sin theta we can find out the value of sin theta is equal to ay, means perpendicular. Okay, sin theta is perpendicular upon hypotenuse. This is the trigonometric ratio, perpendicular upon hypotenuse. So for perpendicular we can write ay, which will be the magnitude of vector ay. Ay upon a, which is the magnitude, is sin theta, and ay, the magnitude of the vertical component of this vector, is equal to a sin theta, and the vector form that will become ay, which is a vector here, that is equal to a sin theta here is unit vector for the perpendicular is j. Okay, and if we have this vector in three-dimensional system, then there will be we will use for example az, that will become a, again sin theta will be used for this one. Okay, but I think we don't need to write this here. Now we know that this is a right angle triangle. AX is the base, AY is the perpendicular, AN is the hypotenuse. So by applying to find out the value of the vector A, we can use Pythagoras theorem here. So Pythagoras theorem is this one, hypotenuse square. Okay, first write hypotenuse square. Hypotenuse square is equal to base square plus perpendicular square. Okay, hypotenuse is A, and we will put the magnitude of this one. So A, vector A, we can write this formula for the magnitude too. We can write only A without this symbol, this sign, or we can write in this form. A square is equal to base square. Base square is AX. This is the magnitude of the AX. Base square plus perpendicular square, which is AY square. Or we can write like this one, A square is equal to AX square plus AY square. This is the same one. We can write for the magnitude in this form, or just only AX. So A square is equal to AX square plus AY square, or A is equal to taking square root of both sides. So AX square plus AY square under root. This is the magnitude of the vector, because by Pythagoras theorem we can find out the value of the vector A, because this is a right angle triangle and we can apply the Pythagoras theorem here. So this will be the value of this one. And for the direction, for this theta, we can find out by using tangent theta. For direction, or for theta, direction means for theta, tangent theta is equal to AY upon AX, means perpendicular upon base. This is the formula for tangent theta, AX. So theta is equal to tan inverse AY upon AX. This is the value for the direction for theta. To find out the theta here, for the vector A, we will use tangent theta AY upon X. If you have the value of AY and you have the value of AX, the value for the vertical and for the horizontal, you can find out the angle of the vector A, which makes with the x-axis. Okay, till this point it was the resolution of the vector. Till this point it was the resolution of the vector, how a vector can be split or can be resolved into its components. So this was the simple way, by dropping a perpendicular from the tip of the vector on the x-axis, and you will get two components of this vector. One is the horizontal component, which is AX. The second one is the vertical component. And the formula for these horizontal and vertical component, we got it here. AX is equal to A cos theta, or in the vector form that will become AX is equal to A cos theta I. Okay. And for the vertical component, we will use the trigonometric ratio sin theta, and the value of the magnitude of the vertical component is AY is equal to A sin theta, and vector form that will become AY is equal to A sin theta J. J is the unit vector, which is unit vector along the Y axis. Okay. So this was the resolution of the vector. And this one, this one from here to this one, this is the composition of a vector from its component. For example, you got the two components AX, you got the component AX, you got the component AY. So by using Pythagoras theorem, you can find out the value of the vector A. This, we did this one, resolved this one, and now we are just adding both of them and we get again the vector A. So if you have the components AX and AY, so by this formula, you can find out the vector A. And if you have the vector A and you need to the component of the vector, by resolving that vector into its component, you can do that. And if you have to find out, for example, this component has been given here, this component has been given here, so you can find out the magnitude by using this method, and you can find out the direction of vector by using this method. Okay, so now these are the two topics. One is the resolution of vector, the second is the composition of vector by its component. Okay, from here it was the composition of vector by its component. All these things are being given in the books and in different notes, so you can study the whole work. You can look for the whole work in the notes. So notes is also available, so you can check that all this this work in the notes. Here I'm just explaining, trying to understand, trying to make it easy for you to understand this one. And the work has been given here, and different books are available in the market, and different notes are available in the market. So you can purchase these notes in those books, and you can learn, you can memorize this from these notes or books. So I'm just only trying to make it easy for you to understand this one. Okay. Now the next topic we will be studying here, that is the addition of vector by its rectangular component method.